Red Hat OpenShift is the sponsor for our container platform coverage from OSCON in Austin, Texas. OpenShift reaches across open source communities to collaborate for healthy upstream development. The goal? Ensure the support for features and functionalities that end users require across the overall ecosystem. You can learn more at openshift.com. Hey, it's Alex Williams of the New Stack here at OSCON, and I'm joined by Ilan Rabinovitch, who works at DataDog and works a lot with developers and helping manage the community over there. And today is the container day here at OSCON, and we're focusing on container platforms as a topic. And I just thought we generally would just talk about kind of, your observations on the community, how what's happening in the market right now. I'm curious from your perspective, what is it you're seeing happen in the Kubernetes community that you find interesting, that you find noteworthy? It seems like it's grown quite a bit. Have you looked at it, from any quantitative perspective, or is it any other, any kind of insights you can give into what, how you think it's progressed?
I think one of the things that's so exciting about this community is the number of companies that are getting together and collaborating on in this space. Today we're here talking about OpenShift Commons and Open Container Day at OSCON, but so you definitely have OpenShift, wrapping Kubernetes and offering a PaaS type experience for developers that want to get their applications out. But there's dozens of other companies and individual developers as well that are diving into this thing head first. And so it's.
But why? Why are they?
We all got excited about containers and this idea that we can spin things up and down very quickly. But it turns out that if you don't have tooling to make that flow easier, you're just actually you're creating more complexity for yourself, not less. And so that's where things, whether it be Kubernetes or DCOS or Cloud Foundry, a lot of other tools that are out there are there to help simplify that experience for developers, get things off, get code off their desktops and off their out of their their Git repos where they're not particularly useful to customers or anybody, and out into production as quickly as possible and as repeatable as possible. And so from our perspective, we're excited about it because it offers there's quite a bit to monitor in that space. There's a lot of room for the more that's changing, the more you want to monitor it to make sure that it's changing in a positive way. And so that's where Datadog fits in with our Kubernetes and OpenShift support. We're part of the OpenShift Commons as well. But from our customers' perspective, it's the goal is to make things as easy as possible for their teams to get out the door and as repeatable as possible.
So didn't we know that this would happen? Didn't we realize that there would be like these units of containers that we were deploying and needing then to move on from there?
I think we did. We've started. Orchestration, container orchestration, or this PaaS type offering that people are building it's not a new thing. There's been lots of starts at this over the past few years, but I think this is the first this is the first community that's been collaborative to this level. And you have folks like Google bringing in a decade or so of container experience to the table as well, so that we're taking those production learnings as we're building this, and so that's I think where a lot of the excitement comes from. So with your with Datadog, your monitoring environment, was it originally designed for 3-tier web applications? Our monitoring tooling was born in the cloud and sort of has brought a lot of the learnings around what you might want from operating in the cloud to the product. So it can work great in a 3-tier application, but in a lot of these places where we shine, it tends to be microservices, containerized workflows, or dynamic infrastructure, places where things are coming and going. You don't have to use those features. So if you're in a data center with a 3-tier architecture and nothing ever changes, great. There's a lot of fantastic parts of Datadog that will be a good fit for you. But the place where we shine, the place where we beat out a lot of the other tooling out there, tends to be in those dynamic environments.
So those dynamic environments, are like those microservices environments.
Yeah, dynamic being anywhere where you're programmatically defining your
Right.
infrastructure and it's changing over time. And it seems like microservices tends to go hand in hand with that type of a dynamic workflow.
Now we're kind of moving into this new space where, we're seeing microservices emerge, as a way for applications, to be developed and managed. How do you guys, approach the management of those components, that make up the microservices, because they can be coming from any number of places, and how does that then fit with container orchestration environments?
So the way you define your graphs or your your alerting within the Datadog platform is all tends to be tag based. So you form a question using those tags or a query where you say, I want to see the web error, the error rate on web requests to application X on, data center Y, and you put, each of those, X and Y being tags that you pull in there. All the infrastructure that we're interacting with, whether it be your PaaS platforms like OpenShift or, Kubernetes underneath or Docker underneath that, or even your cloud providers like Amazon and Google, everybody's adopted this idea of tags and labels. Mm-hmm. And so what we're able to do is ingest all of that, bring it into the Datadog platform so that when you're creating these alerts in the monitors, and as these things are moving around, they're being, rather than saying, tell me about server 1 or container 1, you say, tell me about this application. And you come up with a question that will be true whether you have 100 containers right now or 200 containers or 1,000 servers. As things are growing and shrinking, the query still returns the business question that you wanted answered, which is, how many errors am I returning to my customer from my website right now? And so And it turns out that as we start to think about our services rather than our individual hosts, those are actually the questions we really cared about anyways. Your CEO doesn't show up and say, server number 1 looks sick.
Yeah.
Can you take care of it? What he says is, customers are complaining that the web requests are taking too long, or that they're not returning, or that the shopping cart doesn't check out, or whatever it might be. And as a result, these higher level service questions that we're talking about with the tags are really what you're interested in as a company. They're the things that you do want to wake up at night, not that CPU is high or that disk is low. So
how does that distinguish you from other services that are in the monitoring business?
A lot of them tend to be more focused on the individual host or on low level resource metrics. So they're worried. Their goal is to they're going to help you trace whether it's low-level system calls, or they're going to help you trace how an individual container is performing within and of itself, and that's great. It's just not as interesting as we can do that as well. But it's not as interesting as when you aggregate it all together and think about your.
Why is that not as interesting?
If you have a cluster of 100 servers and they're all doing the same thing together, why do you care? You in a troubleshooting scenario, you do care about how that guy might be looking. But in general, we're in this environment where you can just shoot that container, recreate it, or kill that instance, recreate it. You're more interested in the cluster level as a whole, and as are your customers. We can collect the data at that level, but you're much more interested in how your overall organization is performing than how one node in that organization is performing.
Mm-hmm. Mm-hmm. So tell us how you approach that aggregate then. As opposed to the single container approach.
So again, what we'll do is we deploy a sidecar container alongside your other containerized workloads. We'll collect that data locally into our agent. So whether that be custom metrics from your application, or metrics from the container itself in terms of how many resources it's using or what have you, we bring that into our hosted platform, the Datadog platform, and we'll turn that into where we aggregate all that data together. We also pull in data from other monitoring systems, from your cloud providers, from all of the different parts of your stack, so that you can see it in one place. And then based on the fact that we've applied all of those tags we talked about earlier, you can construct interesting queries about your environment.
How do you monitor then the individual containers themselves to know that they're, for example, they might be that they're safe, that they're usable, that they're.
So just like anything else, a container name or a container ID is a tag, and you could hone it down to just that. You could construct a query that says show me things that are about a particular container image name, and so as you construct your questions, you can be as fine-grained or as coarse as you want, and so you keep diving in on that.
Do you scan the container itself?
So we're not. I mean, what we'll do is we will monitor the process that container exposes. So, for example, let's say you have Redis or Nginx running in that container. Our agent will connect to that and get the statistics about Redis or about Nginx and how the metrics about how it's performing.
How does that differ from scanning mechanisms that other monitoring platforms use?
So when you say, when you say scanning, I want to make sure we're talking about the same thing. I mean, there are lots of like security scanning tools that are out there that will, like Claire from the CoreOS folks, and the Docker guys have their service as well. These are more about.
What's Google's new? Is a C? What is it?
Talking about like C Advisor. So C Advisor is one of the data sources that we will use to get information about how those containers are performing.
Okay.
There's lots of different sources, and the thing is, over the years, everybody's built all these different point solutions for interacting with monitoring data. So if you're a Hadoop user, you're probably using something from Cloudera around their Hadoop management tools. If you're a Cassandra user, you likely have DataStax's Ops Center. And so as you build all of these point solutions out, it's hard to look across all of them in an incident and try to figure out how all these different pieces align.
That's what I'm wondering is like, how do you know what the constraints are. When is it? When do you know if you're going to be? When are you going too granular? When you're not going enough? Like how do you guys make these? Make these judgments yourself when you're building your own services?
So I mean, we try to follow our own lessons that the lessons we teach our customer. We have a set of guides on our blog called Monitoring 101. And I think actually we published these on the new stack as well. And so that framework really helps you to, as you think through which of your metrics are work metrics, the things that you're outputting, the things that make the things that your customers consume, versus your resource metrics, the pieces that go into making that API call happen, whether it be CPU or network or what have you, and then the events around it that give you context. As we, if you by going through that framework, it becomes very clear what your key metrics are as a service, whether that's whether you're providing a service to your end customer or you're the DBA providing a data tier service to the rest of the folks within your organization. Everybody has this work metric or this work output that they do. Identifying what that is, that's the metric that you care about. That's the place where you want to make sure you're delivering on your SLAs and on your promises. And so by going through that workflow, and I'm sure somewhere in the podcast notes there'll be a link to this blog at some point on the new stack. We can you can help identify what those key metrics are for your organization.
So now increasingly we're going to see developers building, building their services on distributed platforms, right? I don't see us quite there yet, but it's evident that it'll become easier over time to build applications across multiple cloud services. How does monitoring behave in that how does your monitoring service behave in that that kind of environment? Do you have that capability to monitor that? Across these distributed services that do exist across distributed platforms, and how does that work, or is it basically what you described?
I mean, it's very similar to what we described earlier. The reality is it for the most part just works. I was meeting with one of our customers earlier in the hall here, who was telling me they're doing exactly that. They're running containers on AWS. They're running containers on GC because they want to have they want to be in data center. They want to have both a backup to their current provider, but also they want to be in locations where one or the other doesn't have data centers yet. As part of that, they're as they're constructing these monitoring queries and they're looking at these metrics, which cloud provider you're in or which data center you're in just becomes yet another tag. And so it becomes very easy to say, first you say, show me all of the, web error rates across all of our data centers. And then you say, show me them to me by data center, or show them to me only in this data center.
Right.
And it turns out that those tagging based primitives, the idea of building your queries for building your alerts and your dashboards as queries with predicates, using tags, provides you quite a bit of power, and so that applies in all of these different scenarios.
So, so now you're looking at the ecosystem out there, and there's a lot of different monitoring services that are emerging. There seems to be new ones every day. The CNCF is now I don't know how to describe it, but they've announced that Prometheus is a project that they're working on, and you guys work with OpenShift, and in the Kubernetes ecosystem. How do you guys then consider them Prometheus, as a service? Do you think of it as something that can enhance what you do? What is your guys' point of view when you look at something like that?
So I think it's still early days, and we should it's something to keep an eye on with regards to what the monitoring ecosystem, especially around things like Kubernetes and DCOS, looks like. At the end of the day, we're a service offering. Our customers come to us because monitoring is a complex big data problem, and we help make that simpler for them.
Right.
And so Prometheus being an open source project, it's definitely something that you would be running yourself. There's definitely on a feature per feature level. I think we've been around a bit longer and have a bit more under our belt. But that's, from my perspective, the fact that we're all excited about monitoring and metrics again after a decade of sort of the dark ages around monitoring, where there was, about 5 years ago, there was the Monitoring Sucks project, and now we're in this era of monitoring love, where everybody wants all of these metrics. That's fantastic, right? Let's focus on how helping people make on-call lives easier. They're not waking up in the middle of the night every 5 minutes to deal with spurious alerts. Let's help them be successful as they're doing their deployments. And I think there's room for collaboration and in this space, and helping level up what monitoring does versus what it was doing 5-10 years ago.
So tell us about Datadog right now, and what are some of the challenges that you guys see out there in the market from a technology development perspective? What are some of the hard problems that you guys are trying to solve?
I think you're going to start to see more and more folks looking at algorithmic and programmatic ways of interacting with their alerts, right? You can't tell when normal changes from minute to minute. You can't necessarily look at a graph and say that a spike or a dip is good or bad. So I think you'll start to see more of that developing over time.
Because that's a major problem, like constant alerts, not knowing which one is like the right alert, which one's not.
Right. So I think you'll start to see more of that.
There's a lot of services that
we have a feature we call outlier detection that uses clustering algorithms for that. I think that came out late last year. That's been quite popular with our customers. I think you'll see more of that type of stuff coming in this space, just as people try to apply data science to their operations, and be more focused on the signal and less focused on the noise. I think, and the other piece is that just the velocity at which things are changing is only increasing, right? In the talk earlier today, I mentioned we were seeing VMs stay around for 12 days. These days, containers are somewhere around 3 days on the median. That's
still long. That's still longer than I would think.
It's still quite long, but imagine if we had that conversation 5 years ago or 10 years ago. Where people were naming their the pet versus cattle analogy exists because people were actually naming they're naming their servers after the solar systems or Greek gods or what have you, because they thought they were going to be around for 6 months, a year, 2 years, right? Even in the case of VMs, I'd worked in organizations where you have a VM that's been around for 2-3 years, which is insane because it's programmatic disposable infrastructure. Why aren't you doing that? And so that's we're, like I said, back in October October we saw it was at 12 days for a VM, 3 days for a container. I think you're just going to continue to see that drop to the point, especially as folks are adopting orchestration tooling like Kubernetes, like OpenShift, like DCOS. They no longer have to. They're not managing this stuff as manually as they were before, and so things are going to get moved out from under them all the time.
But that creates so much data, doesn't it? I mean, the amount of data. So tell us about your data stack. What does your data stack look like for managing data? What are some of the open source platforms that you're using?
So we're at nearly 3 trillion metrics a day data points a day that we're collecting from our customers.
Wow.
Millions of events.
What do you project on that?
So I'm not. I mean, in terms of events.
Events. What would you like? I mean, should we see 12 trillion and by this time next year?
I wouldn't try to speculate on something like that. I know. I think we can have that conversation. I think in a year when we come back here to
Well,
OSCON.
I mean, I guess it depends on your customer base.
Yeah,
but in many ways.
But I mean, it's just growing all the time.
But are you seeing the question I think that I'm getting to is this exponential increase in data, may correlate to customers, but it may also just correlate to the fact that it's just growing so exponentially.
It's both, especially in this container space as people start to do more density per node. Again, back in October we saw it was about 4 containers per node. I would venture to guess when we we go back and look at the data, it's going to be even more so now. And so that just from that perspective it grows. Our customer base is growing all the time, so there's that as well.
So what are you using to ingest your data?
Our stack looks, we use there are data stores that we built ourselves from scratch that are proprietary, but we also use things, amazing open source technologies like Cassandra. We use things like Kafka. We use things like Postgres is our primary RDBMS, and there's we've got some great blog posts on how to monitor all those pieces, but also talking a little bit about how we use those in our infrastructure. And we're here at OSCON, so we can focus on open source. I mean, that these days the default answer to most of this infrastructure plumbing is open source. It's amazing. 10 years ago that wasn't the case. You come here and you thought we thought we were in a you would come here and you would be special, the fact that you had you were using all of this open source technology, or people would be surprised that you were able to scale on it. Nowadays it's the default. The Apache projects are often the default choice in how you go approaching this.
Right.
If you look at the container space, there's not a ton of proprietary container solutions out there. It's all, whether it's Docker or Rocket or anything else, they're all open source. They're all being done upstream.
I guess that's just going to be, such a big question for us. Is a big focus for us this coming year is on kind of the mega theme of automation.
Right.
And when we think about just companies that are spawning billions of containers, right? The amount of data associated with that.
It's going to be. I think you're going to see some amazing growth over the next year, both in the container usage as well as in the data that they generate.
Well, I could see all kinds of conversations we could actually have about different aspects of what are the machines that are going to be ingesting this data and everything else.
Right.
But in the meantime, I just want to thank you, Ilan, for taking the time to talk with us today.
Yeah, thanks for having us.
And we'll follow up soon.
Sounds great. Thanks. Alex. Thanks,
Bye-bye.
everybody. Bye.
Red Hat OpenShift is the sponsor for our container platform coverage from OSCON in Austin, Texas. OpenShift reaches across open source communities to collaborate for healthy upstream development. The goal? Ensure the support for features and functionalities that end users require across the overall ecosystem. You can learn more at openshift.com.